We are here at Infineon in San Jose Champion Court. My name is Al-Attiyah. I'm a staff specialist for artificial intelligence here at Infineon, and I will be the moderator for the session today. A few information before we start with our speaker. So first of all, we would like to thank the tinyML strategic partners. I will briefly go through them. I would like to thank 8zip, Arduino, ARM, BrainChip, Edge Impulse, EmbedUR, Efficient, Green Waves Technology, Grovity, IMAX, Imagimob, Infineon, Inaterra, Note AI, NXP, PNG, Qorvo, Qualcomm, Renaissance, Schneider Electric, SensiML, Sony, Silicon Labs, ST Microelectronics, Synaptics, Syntiant, and TDK. And we would like to also highlight two growing community when it comes to tinyML. So the first is the Meetup community with 20,000 members registered. And the second is the tinyML community in LinkedIn with 60,000 followers as well. You can find the links and the QR code here, so feel free to take a look and also join the community. This session will be recorded. We will also make it available in the YouTube channel from the tinyML. There you could also find the past session that has been recorded with more than 600 videos. And feel free to also subscribe to the channel if the topics is for interest for you. And there are currently more than 20,000 of subscribers. Last information and highlights before we get started. It's about the upcoming tinyML email summit that will take place in Milan end of June, so from the 24th to 26th of June. And it's an in-person event, and you can register here from the link that you find. And with that, I would like to introduce our first speaker of today, Moenes Iskarous. Moenes is passionate about embedded development. He has been in industrial experience for more than 32 years, especially in semiconductor industry with big focus on machine learning technology development. He holds a PhD from the Vanderbilt University with focus on neural network architecture and robotics. And before Infineon, he has been working at C-Cube Microsystem, Intel, and many more. And he's currently the CTO for IoT and AI, leading the Machine Learning Center of Excellence here at Infineon. And our second speaker of today is Sam Al-Attiyah. Sam is working at Imagimob. He has been working at Imagimob for more than 7 years. He's currently heading the customer success team at Imagimob, and he's also product manager for the Imagimob ready models. And Sam has a master in electrical engineering, having studied both also in Australia and Sweden. So welcome to the speakers, and I would like now to hand over to Moenes for the first presentation of today.
Thank you, Elena. So the agenda for today will be very briefly talking about IoT at Infineon, and then the embedded edge intelligence, especially with the new products that we just announced recently. And then Sam will talk about Imagimob Studio, and we welcome all the question after from the online and in person here. And then after we finish, we'll have a networking time and demo. So IoT at Infineon. Infineon has actually multiple divisions, and IoT is one of the main and critical ones for Infineon. And it's targeting consumer, industrial, automotive, and there are of course other divisions that Infineon is leading in the world, like power, like security, and automotive electronics. What is critical for all of us to think about is the IoT and AI together. It's a major trend that we are all aware of with tinyML and with many other directions that include the compute, the actuation, the sensing, and the software. And what's also very important is the security aspect, security around all of them. AI models, data going into the for processing and connected to the cloud and so on. Very critical to have the security solution, which also Infineon is have a very prominent role in. Now, what we want to talk about today is our new product, which is the PSOC Edge. It's a family of microcontroller products with the targeting AI for IoT and for edge applications. As I mentioned, AI is now becoming very critical in many applications where models are trained on the cloud, running all the inference on edge devices, different edge devices from industrial to consumer to automotive. Infineon is at the center of this, and you probably all know the big benefits of running AI inference on the edge in terms of the low latency, power saving, security and privacy, and also the total cost of the system. And these are all addressed by Infineon with these products. In general, there are many markets that Infineon contribute to and is addressing, from services to building the end-to-end AI ecosystem, from the model, data model selection, training, optimization, deployment, and so on. And Imagimob, Sam is going to talk more about the Imagimob Studio and the role of it in that, as well as, of course, the silicon, the hardware, all the MCUs and all the MCU families that we provide. Just at high level, and Sam is going to address this in more details with the Imagimob Studio that we have now as part of Infineon, and also integrated with the Moenes Toolbox, which is our software development ecosystem or software development tool. We can support bringing your own model, bringing your data, buying or providing a ready model that is fine-tuned or tuned for your application, from the data, getting the data, acquiring the data, and training the model, and selecting the model, optimization, and then the hardware-specific optimization, the deployment, and a full life cycle of maintaining the models and your deployment. As I mentioned before, AI or applications for AI that Infineon are targeting range from IoT and consumer into AI in automotive, applications of AI in automotive with the security and safety critical application and reliable application, as well as industrial AI for quality and efficiency and general analytics. I'm going to focus more today on the IoT side. So this is specifically on the IoT with all the our offering, starting from the software and the AI and the development ecosystem. Again, with Imagimob that is going to be presented soon. Different software development tools and partners, and then the actual microcontrollers, PSOC 6, which has been a family that in production for quite some time, and our new family, PSOC Edge microcontrollers. Infineon also provide different sensors and connectivity and security solution. Very critical to have all these together and integrated in one environment that you can use for all of them. So PSOC Edge, what is PSOC Edge? We just announced the PSOC Edge family. and with 3 different flavors, the E81, 83, and 84 MCUs. The general target are, as shown here, for smart home, for cameras, security cameras, for robotics, for human-machine interface and wearables. And there's a list here. I'm not going to read it, but for different target kind of items or use cases within each one. So what we offer for, and I'll talk a little bit in more details in the next few slides, with the PSOC Edge is high performance and low power compute, which is typically very hard to achieve. You have either high performance and you consume a lot of power, or you have lower performance for low power. But we're trying to balance this, because at the end of the day, it is about the trade-offs that you do for your solution. Memory resources, very important within the SoC integration. Security, as I mentioned, is very important to us. Now that we have the different security standards that we support, so we have the Edge Protect technology 2 and 4. With E81, PSOC Edge E81, it is the entry-level enablement. And then the next one is that has a higher or a better and higher performance machine learning capability. Even with the 81, the E81 has machine learning capability, but the high performance one is actually with the E83, and E84 has more capability, especially on graphics and user interface. So we can see the different levels of PSOC Edge from E81, E83, and E84. Yes, E84. So if we look at just a high-level comparison between them, each one has actually 2 Cortex-M MCUs. So all of them, they have an M33 MCU and an M55 MCU. With the M55, the DSP associated with it for the high performance applications. We have actually 2 domains. One is the low power domain that is for the M33, where you can run always on applications that are battery operated or very low power, that require very low power. And then we have a high performance domain with the M55. From the Edge, PSOC Edge E83 and E84, then we have the Ethos U55 accelerator, machine learning accelerator for high performance machine learning applications. Associated with the M33, which is in the low power domain, there is an ultra low power machine learning accelerator that we call NN Lite. And this is so that if you are running an application then that requires a continuous monitoring, low power, very low power, always on, and you want to use some machine learning capabilities, you can run it on NN Lite. And then once you need a high performance capability, then you wake up the M55 and the U55 and run your high performance capabilities. There is also some differences in the internal memory, especially the SRAM size for the different offerings. And all of them support the some security features like the secure enclave and the Edge Protect category 2 and 4. In the next few slides, these are more just I'm not going to talk about the details, but these are the different blocks within each of the flavors of PSOC Edge. So this is the E81, and then with a secure enclave and system resources. When we go to the E83 for supporting computer vision applications and audio and speech, and then E84, the high end with the graphics interface. The other thing I want to talk about is, as I mentioned, is security is very critical for edge AI applications. Securing the models, securing the updates, securing the data from the data stream, the entire data path from the sensors to compute all the way to actuation or for sending to the cloud. So there are multiple and several security features that are offered within PSOC Edge E81, 83, and 84. Currently, we have silicon, we have development kits. They are actually available to our alpha customers or any developer who are interested to have early access. It's not yet publicly available that you can go and buy, but will be coming around next year. But if there is any interest, please contact us and you can be part of the alpha customer program. Just to summarize, and we'll come back to this with the questions. Why Infineon AI solution? First of all, it's an end-to-end solution that we provide from the development ecosystem, the different offerings of silicon, the security, and all the different features. We also want to provide features that you can customize and apply it to your specific solution. Again, it's all about trade-off between power, performance, BOM costs, features, and so on. And reliability and safety is very critical with our applications. So hopefully we would like you to know more about the PSOC Edge. And if you are interested, please contact us to learn more. There is, of course, a lot of material and information online that you can get additional information. And with this, I'd like to turn it to Sam to continue the discussion with Imagimob as our end-to-end development ecosystem.
Thank you, Moenes. Yeah, so now I'll be talking about the Imagimob Studio, which is our development platform for developing machine learning models. And how I wanted to format this presentation is essentially to talk a bit about the history and why we developed a platform for you to get an understanding of what is the point of it and what value does it bring. Okay, so yeah, to start off with, we started going into Edge AI in 2015, and this was very early on. So essentially, we were on our own in terms of development. There was no existing functionality, no tools. We needed to kind of break new grounds, and this was kind of this is where we developed our platform. It's not the Imagimob Studio that we developed a couple of years later, but it was kind of the precursor to it. And here the idea was very simple. It's to make the end-to-end process easier. So looking at how we can make data collection easier, have the tools for analyzing data, being able to train our models and get the models ready for deployment, and do all of this with also having the possibility to customize and have this functionality for different kinds of customer projects. So different kinds of sensors and different kinds of use cases. And this is where we come into Imagimob Studio. So kind of the philosophy behind the studio is that it's a cyclical development process. So the idea is you can jump into the platform at any part of your journey and jump out, and also that you can go between the steps very easily and go back and forth. So again, the idea is to collect your data or import your data from your different sensors to be able to easily label and annotate this data, to have the tools and functionality for managing your large data sets, to have functionality to be able to process your data and extract different kinds of features and generate different kinds of information from it, to be able to generate different kinds of models, different kinds of machine learning models, and evaluate and select them, and finally package them and deploy them. And the idea is to kind of go from left to right, but also kind of go around and continue to improve the model until it's finally ready for deployment out in the field. So yeah, let me jump into the first part. So data collection can be quite tricky. Essentially, you have the problems of how am I able to get data out from my devices? So it's different devices out in the field, different kinds of sensors. How do I synchronize it? If you have two different kinds of sensors and you want to use both of them, how do you make sure that they're in sync so that the machine learning model actually learns the proper information? And also, how do you establish the ground truth then labeling? And for this, we are constantly trying to improve and make it easier and more streamlined. But what we have for customers is this new graphical interface that I will show a bit more later, but it's the ability to add your hardware as a component into the studio. So you can represent your different hardware as just kind of a block and be able to add a visualization node to one of those. And here the idea is that we have a standard protocol that any user can go in right now that does documentation, and they can add support for their devices and begin to stream data into the platform and save it. And the idea here is to make it just super easy and intuitive to start collecting data. And then the other functionalities, being able to add video files alongside your data, which gives you a really intricate understanding of what's going on in your system. So, for example, in the past, let's say doing a complex application like fall detection, it's about being able to look at your data and seeing how does the system react in different parts of the fall, like what happens before you fall, what happens during the fall, and then what happens after the fall. And all of this gives you information on how you can improve your machine learning model. And lastly, it's about kind of removing the pain points for users. So one big problem, other than data collection, is data labeling. And what we try to do is to have lots of different ways that customers can label, like either by selecting a section of your data and tagging it as a specific event, or being able to use our machine learning assisted labeling, or being able to use an algorithm based labeling. So then the next problem that we had is that, okay, we've solved the problem of collecting data, and now we have lots of data files. It could be in the thousands or tens of thousands, depending on your project. So how do you categorize them? How do you get different information out of them? How do you manage them? And let me give you an example. We worked on one project where the customer didn't realize that some of their data was sampled at a different frequency. So half of their data was using one frequency, and then the other half was sampled using 10 times higher frequency. So of course, from the model, it looked like some events were happening 10 times faster than other events, even though they were the same events. So the idea within the platform is that it helps you to catch this kind of cases, which are very common because just human error when you're dealing with 10,000 files. How are you supposed to know that 1,000 of your files were accidentally sampled with the wrong settings? And it comes to, it's the same thing with frequency. So for example, you have one of your devices is not working properly, it's dropping a lot of packets. You don't know it unless it visualizes it and gives you a warning. So that's kind of the idea, and then to also give you some information about your different classes and different labels, and essentially empower the user to understand what's happening on this system on a high level. So then essentially you've gathered your data set and you're happy with the amount of data. Now kind of comes to the complicated or arguably interesting part, which is actually working with your data and improving your models. So there, the problems that we try to solve is how to make sure that the improvements you do one time actually carry through to your other projects, so you're not really reinventing the wheel. And the idea is here kind of the concept of a library. So within the platform, you have a library of different layers that you can continuously expand. So we ship the platform with the specific set of library, but it's possible for the user themselves to create their own private library that they can import into the platform and have their own special functionality. So here it's all about being able to apply different kinds of mathematical, physics-based feature generation in order to highlight some features that makes it easier for machine learning models to learn. And in the case that we're in, which is very domain-specific machine learning models, it can be quite important. You can't just dump lots of data like you can with vision applications where you have billions of images into a system and let it learn. You have to, it's hard to collect data, so we don't have so much data, and that means that highlighting some basic features for the model helps it to learn so that it doesn't need to learn everything from scratch. It can work off these features. And then lastly, the idea is to allow people without machine learning experience to be able to generate models by just having a simple interface and selecting some options from the drop-down menu and from the different tabs, and generating something that's good and that's based on our experience of which kind of models perform well. But also allowing more experienced people to go in and adjust the different settings to add their own custom networks and things like that. So the idea is to help both ends of the spectrum. Yeah, and I kind of touched this on this a bit, but the idea of the platform is to have different ways that you can really process and understand your data, so visualize it in different ways. And here the problem is that every problem is quite complex. and you need to have the flexibility to analyze it in different ways. So here what we're seeing is that you can see the time series data, you can see the label, you see the model output, and then you also see the Fourier spectrogram. So you can keep building on top and visualizing different aspects of your project. You can also add video files that allow you to see what is exactly happening at this moment in time. So one example that I like to give is that when we were working on fall detection, for example, the first instinct is that when a person falls, they go into free fall, which is a great first impression. But then when you actually look at the data, you realize, okay, but if the sensor is on the wrist, the first thing that the person is going to do is actually push their hand out to protect themselves. So having the video to so that you can actually see that, and then seeing how does that look in terms of the sensor data gives you a lot of information about what happens during the event, which helps you to encapsulate it better and helps you to give the right features for the model to learn. And then the next thing is that, okay, you have a trained model, you have analyzed it, you have made sure that it works correctly. What's the next steps? So the problem here is that it's two primary things. Like one is that you don't want to go through the whole hassle of translating your model to the edge. Like you don't want to have it be a long process. You want to focus on making sure that the model works well rather than focus half of your efforts on how to get it onto your devices. So the idea here is to make that really easy. And another thing is that you don't want to have to reinvent the model once you get it onto the edge. So you want to have the certainty that what you see is what you get. And kind of starting from the way down, that's something that's now possible with the graphical interface. So what I showed earlier is being able to collect data, but when you have a live stream of data, you can actually pass it through the model and then actually visualize the output. So this lets you test your model in real time and see what happens on the different kinds of systems. So when your model is working perfectly fine, then this information might not be so valuable. But if you're doing your alpha testing and then you have a false positive or false negative in the system, the first question you're going to have is, why did this happen? And by being able to analyze that, you can look at different aspects and conclude why this happened, but also you can save these recordings and then include them back in the training so that you can ensure it doesn't happen again. And so this is kind of how we see as kind of the first step of deployment, and then it's about making it easier to really have it running on the device. And this means like fully encapsulating the entire model. So what you put into the platform is exactly what you need to put on the device side, which means that you don't need to recreate anything. So essentially how we work with it is that every time you get a new sample from your sensors, then you just put that into the model, and then the model takes care of the rest. So all of the buffering, the processing, the architecture, and post-processing. And then the idea is to give the user a simple API, have data in and have data out. And then everything is encapsulated inside. And then, of course, it's about being able to target different devices. So here I have the shown screenshot of the PSOC 6. You also have functionality for the PSOC Edge, so you can package your model for that. So yeah, essentially what I want to say is that we developed the platform to really make it easy for users to be up and running, but also have all of the functionality that you need to actually do a real application. So the important thing for us was to be able to really work with your data, to visualize different aspects, to to manage your large data sets, and also arguably most importantly is to be able to customize your project. So being able to add different kinds of custom units based on what you see works for your system, which really unlocks the full potential. And the idea there is that once you add a unit into the library, that you can use for other projects as well. And that's, for example, what we do inside the team. So we work with different kinds of processing, and then when we see that something works, we ship it out to the public. So you can go to our website right now and download the platform. We have a developer community with all of the documentation. And we also now have a forum on the Infineon page, so you can go there and ask questions if you have questions. And the best thing is that the idea is that the platform is completely free for prototyping and development. So there's nothing stopping you from going to our website right now and downloading the platform and getting started. And we have a generous amount of computing and resources. So the idea is to help you guys actually get your models working and get them functional.
Thanks, Sam. Thanks, Sam, and thanks to Moenes for the presentation. So we have now time for some questions. I will start from one that I see in the chat here in Zoom. I think this question is for you, Sam. I'll just read it out loud so everyone can also see it. Can your dashboard for configuring hardware components be used for code generation of the configured data path?
Yes. So that for configuring the data path, that's not ready right now, but that's kind of in our roadmap. So we're hoping to have that out soon.
Okay, thanks. And we also have here Ashutosh, in case there are questions that he might address. He's also here at Infineon Lead Senior Principal System Engineer, and he's happy to also answer any question you might have when it comes to machine learning solution architecture and tooling. Yeah. Are there questions also from here? Yes.
Will we have access to the presentation material after the event?
Yes, yeah.
Perfect.
We will make the slides and recording available for everyone.
And then I had a specific question for Sam. So if you're going to deploy on PSOC Edge, at what point do you need to do quantization, or do you need to do quantization in the model development?
So in the quantization that we focus on is the post-training quantization. So within the platform, you will have a UI that allows you to select the different properties for the PSOC Edge.
Very good. Thank you.
So Sam, the question is for you, and it's about what would be the difference between using Imagimob and other studios out there, so Edge Impulse or other you could have in mind.
Yes. So I guess there are a number of different things. One is that we believe in not having a black box solution. So everything we do in the platform is exposed for the user so that they can see exactly what's happening in the system. And this means that the reason why we have this is because we believe that it's valuable in order to actually put your machine learning in production to understand what's happening in the system. And that means that when it comes to the different processing blocks and different components, it's all exposed. And the second thing is that we have this graphical interface, which the idea here is that it makes it a lot more intuitive to start working with the machine learning, because you can represent everything from physical devices like boards and sensors as a node, but you can also represent functionality, for example, augmentation and connection to cloud databases and things like that, as also a node in the system. And this is what we are really investing in right now.
And on another question, Sam, do you have any pruning or knowledge distillation function on the Imagimob platform?
So pruning, not right now. We have investigated before and didn't find that it worked well enough for our purposes. But this is something that we're constantly evaluating. So different kinds of methods and techniques for really bringing down the model sizes and making them more efficient. But I would say that right now in this moment, no.
And what about computer vision models, like object detection or classification or segmentation, those capabilities?
And so we're right now, as you probably noticed, like we work primarily with the time series data and kind of like how the labeling and annotation works, for example, is to annotate a segment in time. But the idea is by the end of the year to also start adding support for 2D data, which means like vision, but also can be other kinds of radar applications. So to be able to annotate and label your data in terms of in space rather than in time. And this will unlock new use cases, including vision, and this is planned for the end of the year.
So this would mean that it would also be possible then to bring a state-of-the-art models and deploy it on the PSOC.
Yeah, and I would argue that a lot of that functionality already exists. It's more about in terms of development that more functionality is needed in our platform. So if you're curious about deploying vision models right now, then please talk to us and we can see if we can get you up and running.
Okay. And what about dealing with the accuracy degradation, post-training quantization?
Yeah, so here the idea is to give the user all of the information about what's happening with the error degradation and things like that. So we generate different kinds of reports for the user to analyze.
Okay, thanks. Other question from the room?
Yeah, I have a question. So you mentioned the multimode multi-signal radar and the image. Is there any other sources of data also recorded, synchronized, what during the recording?
I'm not sure if you heard the question, Sam. Maybe you could come
Yeah,
on.
I think I heard it. So essentially in the platform itself, there is no limit to how many signals you have. So we worked as you mentioned with the radar where we're looking at the we were using a radar that had an output of 356 frequency bin information. So those were the signals that were input into the platform. We've also worked with the currents and voltages. So from the platform perspective, it doesn't really care how many signals you're inputting into the system, as long as you just do the extra things like making sure that they're all the same sampling frequency and things like that for the model to really be able to understand what's going on. Then what we support in the platform is giving the user the tools to synchronize them. So, for example, what we've done in the past is had 6 IMUs connected streaming data in parallel, and then we did some kind of like a clapper motion, so just hitting the IMUs and then using that inside of the platform to synchronize all of the signals, and then you're good to go.
Another question. when the data is recorded available for the user to train the models, does the user need to deal with the data to do some kind of how deep the user needs to be involved to process the data before it can be used to train the model? For example, the user may have some preference and selective use some data. Can you give some details of this?
I didn't completely hear the question. Was it about being able
selecting some of the data?
Yeah, it's about selecting the data after when you have to do the training of the model, how the user is going to be able to deal with it.
Yeah, so the idea is that you can train a model on the raw data, but you also have lots of processing functions in the library to allow you to transform the data or filter through it and drop signals and things like that.
Is this answer? Other question here from the audience?
There is one.
But it's not about that. So like especially in computer vision, like what is like the time to like make data prep and all that stuff and train the model, and then how long does it like stay in use? What I'm like seeing these days is like the model training doesn't take much time, but like mostly the labeling the data takes most of the time, and then at this like if your model stays like used for a long time, you can like spend all the time. But over the period of time, I see that it doesn't stay that long. So mostly we're just training new more. So what is your opinion on like, how long does it take to like make a model and train the model versus how long does it like, stay in use before you have to do something?
Yeah, let me maybe first repeat the question for the audience, and then hopefully also Ashutosh can answer. But the question is related to, okay, normally we say that most part of the training of the time is consumed by training, but what about, for example, data labeling and those other steps of the ML lifecycle, which are also time consuming? What are your thoughts on that? Not sure if you, Sam, or Ashutosh wants to answer. Maybe Ashutosh, if you answer, if you want to come close to the microphone, that would be easier.
Actually, I think it was also specific to computer vision.
Yeah, for computer vision application,
so,
exactly. Yeah.
Ashutosh.
Right. So from the like a lot of applications we have seen on the like sensors and speech and audio side, the frequency to where the model drift or data drift, that model comes back, has not been, I would say, prohibitive, right? There are use cases where you do see some things come out. I mean, your devices are brought back. And it's not something that is, I would say, out of ordinary that used to happen before, right? This phenomena existed there. So in general, from the, I would say, robustness perspective, right, the models are pretty robust. They are able to learn. There is always going to be model drift and data drift that's going to exist, but that's not just necessarily applicable to neural network. And there are techniques that are utilized before we ship out the products to make sure that the solution is trustworthy, right? And we can go into a bit more of that. Now, specific to computer vision, I agree that you know, a lot of work goes on to data preparation, right? And any solution, either in the computer vision or speech and audio or sensors, the key is to create that robust solution. So if the chances of how long is the shelf life, right, depends on how comprehensively sort of the model is trained. One of the things that's actually different in computer vision as opposed to, I would say, speech and audio is the background training is very tricky in the computer vision. Even if I have to train 5 objects or 10 objects or 20 objects, the background can vary a lot, right? So understanding and training that could be different. So as long as your application is well understood and those aspects are handled, these models, they are able to, you know, exist in the field for a while. And a good example is like person detection model, right? You see a lot of them everywhere, right? They, of course, work out of the box. Of course, you know, they are trained for certain applications with certain things in mind, like one of them is being background. And as long as those are not violated, they do work in a robust manner. So Sam, or you guys want to add something?
Sam, do you want to add anything regarding the computer vision side?
Not specifically on the computer vision, but as I mentioned during the presentation, one of the big challenges for us is actually getting lots of high quality data. So we're constantly looking at different mechanisms to really reduce the amount of data that you need to build high quality models. And this is looking for making it easier to collect data, to making it easy to label your data, to also having functionality like being able to do augmentation and synthesis right within the platform. And finally, to look at how you can train your models more optimally, like doing transfer learning and things like that to, again, reduce the amount of data that you need. So we're kind of taking a holistic view and trying to do something at every single part of the process to kind of make it easier in general.
I have somewhat related question. When you talk about computer vision and background, one of the big problem that usually happens is daytime data versus nighttime data. Have you seen challenges in that field, and how do you solve them?
I mean, the general again, the common technique is augmentation, right, where you have to address and you do need to understand your application, but a lot of that is addressed through augmentation and both from the background perspective, but also from the lighting perspective. So that is something that has to be done exhaustively. And analogous example on the voice or the sensor side is you need to understand what kind of disturbances are going to play in the speech and audio, like the background noise or the reverberation that comes into play. You need to understand on the image side. Also, the lighting is some of the things that affects. Having said that, there are scenarios where you do run out of width, right? I mean, one of the things is like if you install your doorbell that's facing sun, right, there is not much you can do with a regular camera. So this is where to create this robust solution, you go something that's not image sensor, right? So this is at the systems level. You do need to understand there is a limit to physics. If physics violates it, right, AI is not going to solve that problem. So you do need to understand it and fix it.
Thanks, Ashutosh. Thanks, Sam. Question for you, Moenes. Maybe we can repeat it for the audience. So what is the actual footprint of the PSOC Edge?
In terms of the area size, die size?
That depends on a few, packaging options. So we do have some numbers we can
share it, but I don't know it on top of my head right now. Unless somebody here, but I don't think we.
Well, I can just follow up. Is there SMP mounted chip versus all grid arrays?
So yeah, packaging will have to get back to you guys. We are AI guys, so we start at software.
But we'll get you that information. Actually, if you go to the PSOC Edge website, there is a data sheet for each one of the products, the 81, 83, and 84. And if it's not in the data sheet, I'll get you that.
Simpler URL, Infineon.com/PSOC Edge.
Yeah. So maybe as we are talking about it, just want to highlight also these references for everyone. So in the first link, you will find some more information about current Infineon AI solution that you can find. The second is related to the PSOC Edge. So everything we just discussed with all the details about the family, you can find there. And in the last link, you can also find information about Imagimob. Either you want to search for documentation or download the Imagimob Studios. And with that, I think we can close. We would like once again to thank the tinyML strategic partners, starting from the executive strategic partners, so Qualcomm, Sentient, the platinum strategic partners, Embedded UR, Atrios, the gold strategic partners, ARM, Edge Impulse, Infineon, and Renaissance, and finally ST Microelectronics. And also the silver strategic partners that we have highlighted also at the beginning. So thanks to everyone for the session. Thanks also here at Infineon for hosting it. And yeah, I think we can close. Thanks again.